Okay, so picking up with number 30 from chapter 6 of your study guide, asked us to find the slope of the line that would pass through these 2 points. So if you had a graph and you kind of looked at where 1 and 9 would be, the point over 1 up 9, let's say approximately there, then over 5 and down 6, what would you say is the slant between those 2 points? And that's what we're asking this problem. Actually, we use a formula, which is the slope is rise over run, how much rise there is from point, say this point up to this point, the rise over the run, how far over left to right. The rise over run, which can be found by subtracting the y's over subtracting the x's. I'll try to tell you as we go through the study guide problems where you'll need to memorize a formula. Since you don't have a formula sheet, so this would be one. You actually do not have this formula provided, so you need to know how to find this slope on your own. So hopefully if you remember the concept is the rise over run, then you'll know that means the rise would be the up and down, so the subtraction of the y's would do that, and then the run would be the subtraction of the x's, how far left to right. So maybe that will help you. But what you're going to do is subtract your y's, so the 9 and the negative 6, and you can actually subtract in either order. The formula makes you think it's y sub 2, the second y minus the first y, but who's to say which point came first? So you can really write it in either order. But whichever way you subtract it, you need to be consistent with the x's and subtract in that same direction. So I'm going to go 9 minus negative 6. And don't forget, there's a subtraction in the formula, so there's a subtraction plus there was a negative on the number, so it makes a double negative. Now subtract the x's in the same direction, 1 minus 5. So 9 minus negative 6 makes that positive 15. 1 minus 5 is negative 4. So the negative is normally just put outside of the fraction. If you get a negative on the top or the bottom, you can just pull that to the outside and leave it just as a negative overall in the fraction. But definitely there's a negative slant on that. When it goes from downhill from left to right, the way you read a page, it's going in a negative slope direction. Okay, number 31 asks us to look at this picture. So this picture is provided on your study guide, and it determined the equation of the line. And then write it in y equals form. Y equals what? So how are we supposed to know the equation from just this picture? Well, one way is from knowing about slope, like we just talked about number 30. We can determine the slope of that line. We could write it in mx plus b form, which means any equation, any linear equation, I should say, solve for y, we have y equals the slope is always shown, the m value, the m variable means slope. It always shows up in front of the x variable. The slant of the line is in front of x, and then the b is the y-intercept. It's just like magic. Whenever you solve for y, you always have the slope in front of the x and then the y-intercept on the end. All right, so we're going to write it in that form. So figure out the slope would be the slant from left to right. How far is it rising to running? Now you're given 3 points to use from, so you could pick any 2 that you wanted. The slant should be the same whether we go from here to here, here to here, here to here, any 2 points that we pick, because with a line, the slope is always constant. All right, so let's say I go from this point to this point. How many places down? The rise from here to here would be 1, 2, 3, 4 places down, and then 1, 2, 3, 4 places over. So it's actually a 4 to 4. But notice that since it went down, we would say that is a negative rise. We went down 4, so negative 4, and then we ran in a positive x direction, so positive 4 over. So it would be negative 4 to 4, and then we would reduce that to negative 1. So the slope of that line should always be a ratio of negative 1. In front of the x, remember. Y equals the slope in front of the x, and then the y-intercept. The y-intercept is where it crosses this y-axis, and we have that point given to us. The point is crossing at 8, so plus 8. So it should be negative x or negative 1x plus 8. Okay, so the next thing I'll do is go over to number 32, which actually starts chapter 7. It still involves graphing, but we're going to take it up a notch, and we're going to use our graphing skills to solve a system. So now we're going to have two linear equations, and we're going to look for where those two linear equations cross. Where they cross will be the solution to the system. Now remember earlier I said if you just have one equation like x plus y equals 9, there's infinite solutions to that. 5 and 4, 6 and 3, 0, 9, we could do that forever. But if I made two equations like x plus 2y equals 7, if I have two equations involved, now there's only one solution where both of those would be true at the same time. That's what you're doing in Chapter 7. You're finding the solution to the system. For example, if I said I bought two items at Walmart that add up to $9. Again, you can do that a million and one ways. But then if I said one of the items was twice the other item, so twice x plus y equals, let's say, 1, or equals 18. Twice item x plus item y equals 18. Now there's only going to be one solution that solves that. And so we're going to go through some strategies. So you need two clues. And what I want to tell you about my Walmart example, you would need two clues to solve that equation. If you have two unknowns, two items, for example, it takes two clues then to narrow that down and solve that. So that's what we're doing in Chapter 7. We're given two clues, or two equations. And we have three strategies to solve these. We have the graphing strategy, which is like number 32. We'll graph each line on the same graph and look for where they cross. That's really the solutions where the equations run into each other. It should just be one spot. You know, if these are two random lines, there should only be one place where those lines intersect. They can't turn around and run into it again. So it can't have just two solutions. Lines cross in one place. But sometimes, you know, lines don't cross, and the exception to the rule would be if you have parallel lines. And we may see that in one of our examples. If the two lines run exactly parallel to one another, have the same slope, but different intercepts, will not have a solution. And then we may see a problem where we have a line, and then the other line, once we solve it and graph it, winds up being right on top of it. So they wind up just being the same line. And in that case, there would be infinite solutions. Every place they cross, which would be infinite places, would be a solution. So we either have one solution, if it's a normal equation where the lines cross, have different slopes, one solution, or we have no solution if the lines are parallel, or we have infinite solutions if the lines wind up just being the same line, a line on top of a line. All right, so going on now. Number 32 says solve this system by graphing. So we're going to take this first line and graph it on our grid. Notice it's already solved for y, which is a handy way to graph. As I said earlier, if a linear equation is solved for y, you've got the slope in front of the x and a y-intercept on the end. So we can graph this thing by starting with the y-intercept of -1. Remember, y-axis, so graphing the y-intercept at -1. And then remember, the slope means the rise to run from point to point. So if we know this point is given at -1, we should be able to rise 4 and run what would be understood to be over 1. We should rise 4 and run 1 to get to the next point. So from here, up 4, over 1 should give me another point. And now I should be able to do that as many times as I want. Rise 4, run 1 from point to point. And then that will graph your line. Okay, the next one is y equals x minus 4. Again, remember the slope is in front of x. It looks like nothing's there, but it's understood to be a 1, and it's understood to also be over 1. So it's a 1 over 1 slope. This time we're starting at the y-intercept of -4. So 1, 2, 3, 4 is our starting point. Then rise 1, run 1. Rise 1, run 1 from point to point. Connect your dots, and that's the graph of that line. The solution we're looking for is this crossing point where those two lines intersect. Since this is just drawn on the board sloppily, it may not be exactly right on these. On your Math Excel, it should be great though. Looks like it's back 2 and down about 6. I wouldn't swear to it though, but I could check it in the problem and say, I think that's right, it works in this 6 is negative 2 minus 4, and 6 is 4 times negative 2 minus 1. That's true. So I think that is okay. But again, your grid will be more accurate at the Excel, so you can use them. Okay, number 33 asks us to write each one of these equations in slope-intercept form first, and then don't even try to graph it, just see if you can figure out what type of solution it will have. So let's start with the first one. Negative 3x plus 13y equals 1. Remember, slope-intercept form means you're solving for y, getting y equals, so you can see the slope and the intercept. So 13y, I want to keep it here, so 3x is going to cross the line. So I'm plussing 3x to cancel it from the left, which means 13y equals 3x and positive 1. Then divide by 13 to complete the process, and we have 1y, or y equals 3/13. That's going to be our slope in front of x, and 1/13 for the y-intercept. So we have a line with a slope of a rise of 3 and run of 13 that starts at the y-intercept of 1/13. Okay, so hang on to that. Do the next equation, which is negative 3x and 13y equals 7. We want to solve this equation for y as well. So I take the negative 3x needs to go over by plussing 3x. Cancels off of the left. So 13y equals 3x plus 7. Divide out 13 from each side. Y is 3/13 x, that's my slope, with a y-intercept of 7/13. So now I need to interpret what I've got here. And you could graph it if it makes you feel better to see the visual, but know that you have two lines with the exact same slope, but they're unique because they have different y-intercepts. They look kind of similar, the 1/13 and the 7/13, but they're different. So they're not exactly the same line, you know, that line on top of the line I did. They're unique, two different lines with the same slope, so they're running parallel. These are parallel lines, so there will be no solution. Now, Math Excel does ask you some specific questions about that. Whenever they're parallel, we have a word for that. It's called an inconsistent system. So the solution, actually it only asks you to say how many solutions it does have. So it asks you to write each one of these equations out for you and then list the number of solutions, which would be 0. There are no solutions. 0 solutions. Because they're inconsistent. Okay, so we'll pause there and then start up.